So I'm probably going to just spend some time thinking about what to do there on the names. I think the first thing I'm gonna try is to remove the unique name thing that I created. Because I do remember as I was first developing this, that it was working when I wasn't setting the name. So it might be designed to work like this as the default, because it works based on a hash that they create there for each node. So I think that if you don't set the names of the nodes, it just makes the name of the node equal to the name of the type. And if the node with that name already exists, it just increases by 1. So if that's the case, it might be better to do like that than to do it with the way that I have there now, which I'm setting based on a hash sets and the pattern for names there. The only downside is that in that way there is no way to differentiate the nodes you create from code than from the ones from the editor, but I think it doesn't matter anyway, because like obviously it's just very easy to select the node every time you create from the editor. It should be different than the name of the class. But like I said before, there is other problems. Like it's difficult to kind of describe, because I think it's difficult to make it as something that is resilient and that it works. Because my biggest concern is that I create something and like somewhere along the line, because you're creating the whole scene from code, you might mess up the entire scene after you spend a bunch of time creating. So I developed the cache now for this, but still there's a chance that like some errors happen, and then the downside of the error is really big. That's the problem. So the other thing that I was thinking about is like there are situations where I might want to, like after let's say, the way that I'm probably thinking that it's gonna go is that the initial setup of the scene is gonna be done through code, because I can create layout functions. Then from layout functions, you have the initial structure of everything, and it's a lot easier, obviously. And then from that point, I think that's the point where it's probably going to vary a lot. But probably I'm going to change things from the editor because it's easier. Like some layout stuff is probably easier to change from the editor. And then I'm going to have situations as well where I want to put extra elements from code into the scene, but I don't necessarily want to build everything from scratch. And this is the thing that is kind of hard to think about, because the way that I'm designing here, it requires me to always build everything. Maybe actually not. Maybe it doesn't matter that much, because I can always change the code. So like I can change and this part, like there is no way I think it should like make it a standard thing. It's always gonna be like project by project basis. And then like for that reason, I think that makes sense. That's like, let's say for example, I created this scene as up until a certain point, and I have only a state that I kind of like. And from that point on, I just want to add elements from code to the scene. Then what I would do is just comment out the function here, and I would create another function that just creates new elements or stuff like that, and connects to the existing scene. And I think maybe that would work, because I'm always getting the root node, which contains the state of the whole scene in the beginning. So the new functionality that I create would have to take into consideration the current structure. So it would be more algorithms that traverse the tree in a certain way. But I guess this is the thing that is kind of difficult to think about, because the traversal logic is obviously going to be connected based on the name of nodes, because that's the logic that I'm using to update the scene state each time. So depending on the way that I set up the nodes here is going to change the way that I'm incentivized to, or the way that I have to create to create the algorithms that are going to allow me to traverse the tree. Because you can imagine, for example, that let's say I have a scene, and one of the scenes I have a bind set parameters component. Don't remember. Let's say physics is ladder or custom physics, which are the components that are created. So let's say I have a scene that has custom physics, but it has more than one custom physics. And then I want to add a new element as a child of the custom physics. Instead of running everything from scratch and then adding more code, what I could do is just create another algorithm that just takes the scene, the state of the scene, traverses the tree until it gets to that node that I want to change, and then puts the code there. But obviously the structure of the algorithm would be dependent on the nodes. So, not really sure. So I'm gonna try to do it like this. The other thing so there's two different options. One is I can create a variable on the HT manager that is equal to the current scene root, and then I update the current scene root each time that I run here. So instead of here, I would update, because obviously it's going to depend on the scene. So, and then after that, I just call the main function enter points, and then inside of this function here, I would make it based on the root node to set the owner. But I think that's not very good, probably because it increases the chances that I might change a scene. Like I might forget to change the root of the scene, root node of the scene, and then add nodes to a scene that I didn't mean to. So I think it's probably better to do the more like kind of annoying way, just to put scene root here. So that way I force myself to add or to pass the root of the scene every time I add a node. Because what I'm thinking is that it's much better if all of the nodes have the same owner, which is the roots, because of the way that I'm creating the signal serializer there. And I think it makes more sense. So I'm gonna try to do it like this. Oh, the other thing that I realized after I did the previous stream where I was explaining the signal serialization is that the way that the method bind probably works, like the way that the call function from the method bind probably works is determined by the bind method, because it's at the bind method that it's going to subscribe the function. So I wanted to spend some time looking into this, just see if I can understand how it works. So the method is the function pointer. I think I already looked into this some time ago, but I don't remember. Oh, set instance class. Interesting. So initialize method bind with the arguments as the template. method bind t. And then use reinterpret the cast. Is initializing the function pointer. So here it is. So this is the function that is gonna call there. So the call on the method bind is a virtual function because this one overrides there. So when it calls method bind, a call function is gonna call this one. So initializing the menu with this class here instead of method bind. And this one inherits from. I couldn't find it because I searched for a class method bind, not public method bind. So this one is the one that inherits. So it's gonna call this function here basically. And this is the function that is gonna make the call from the object, the methods, and the arguments, argument count, stuff like that. When it's storing the method, I think it initializes with the method, which is the function pointer. So at the moment it creates the function, like this is the address of the function. It's a function pointer that is the address of the function of the class. So it's storing here, and the function is templated, so. And this is supposed to return a variant. So this is another templated function. So here is just figuring out the argument, converting the arguments into variants. And then calling this other one. This is the instance, and this is the one that you always see on the when you're stepping over. Whenever it emits a signal, this is a final function that gets called there. Yeah, so I'm pretty sure that this is how it works. It makes a lot of sense. It's not that difficult to understand. Is it like very confusing because it's C++, but it's completely understandable. And I think that this is a struct that they initialize with macros as well, and it's a template struct, because this one is going to use some variant functionality to convert the types based on the variants logic. But I don't remember really well. I'm pretty sure that's the case. Yeah, so I do remember spending a bunch of time looking into this when I was trying to figure out the variants. But it's basically using dynamic cast from the object to convert the type to, using this remove pointer on the standard library. And I do think it uses other functions along the way on the meet pipeline, meet signal pipeline. But it doesn't matter for me right now, but yes, I think it's pretty easy to understand. When you initialize the method bind, is initialized with the function, which is going to use the other method binds. So it declares as a method bind on class DB because it always declares with on C++ is very common, like because it makes a lot more sense. You declare the type on the file as the base type, and this allows you to on runtime pass whatever type derives from the base type. Because C++ figures out that it is basically the same. And then because it calls from that one, it's going to call this function, and this other method bind that it has from the other one is going to save the function pointer as a member variable there. And then it just calls this, which figures out, dynamically casts the types of each argument based on, with the dynamic cast from the object, using the remove pointer from the standard library. It's not that difficult to. It's very confusing, but not that difficult. So what else was I gonna do? I was gonna change each one here. So first I'm gonna do it like this. There's another concerning thing, kind of concerning, which is when I was developing this, at some point I got to compile and then I ran and then it crashed. And then I tried, I changed a bunch of things there, but each time that it crashed, it actually added more extra nodes to the scene. So, but what I'm thinking about doing, like the easiest way to deal with this, I don't want to spend a bunch of time developing tests and stuff like that because I think it's a waste of time. Is a better, I think, to just create like a mock project that I always use that basically doesn't have anything. To check the first time that I add something new, I just run for that project instead. But obviously, like it could be, there could be problems with this, but I don't care that much, I think. So I'm gonna compile like this first. Then if it works there. The thing is, it's gonna add extra nodes from the, this one already has 3 nodes with our, yeah, I guess the other part that I was thinking about is the state of the signal serializer, like how I'm gonna deal with this. But I guess it doesn't matter that much. I think it doesn't matter because I'm always gonna get the previous one, and then I'm gonna update on top of whatever the previous one had. So if I call subscribe, it just adds on top of the other one. Yeah, but I guess this is the problem. Yeah, so, oh no, but when you remove nodes, it's gonna disconnect automatically. Yeah, but I think that it can be problematic. So let's say like I'm developing from the code and then I subscribe some nodes here, and then later on I remove them from the code. Then the question is like, what happens? Because the class is gonna have the state that was cached before. Hey, what's up? And yeah, but I guess it doesn't matter that much because the worst thing that is gonna happen is that it's gonna have the connection between nodes. Yeah, but it might be a problem because if you remove and then you add later and it wasn't the purpose you have, then it might be problematic, I think. I'm gonna put the lights there. So now let me run this. So it puts other ones there. And it does based on the ID here. It's putting @ and then ID. Interesting. Hmm. So now I'm gonna run again, and then I'm gonna see if if it adds other nodes or it just doesn't change the thing. If it doesn't add other nodes, I'm gonna try to like have a child hierarchy. So add more nodes that should run of the ones that I added through code. I'm making. I'm trying to create something that I did some time ago on like basically a graph on 3 dimensions. So I created this thing, which I talk about all the time, but I created this thing on the front end, like on a website, to visualize a graph in 3 dimensions, and I'm trying to recreate the same thing on Godot. It seems that it's bugged, but it's basically this here. And I'm trying to create this from code. So trying to change Godot's source code so I can create the things from C++ code instead of creating them from the editor. So this is the problem with adding them like that. Can you show HTML instead of Godot? Didn't know that. You developed your own thing to do that? That's interesting. It crashed the thing? Why did it crash? Interesting. How did you do that? You change the source code? I imagine that most browsers probably work in the same way that Godot works. Like they are gonna, obviously they have to work in a similar way. So they're probably using like either Vulkan or OpenGL or something like that. And then like there's an engine behind, and then they just put some logic. I think it's basically the same way actually. It might be different than Godot, but like Godot compiles the JavaScript and then it's basically the same thing. So browsers are compiling the CSS and HTML and JavaScript, and then they communicate with the operational system and the hardware to do stuff. There's probably, and it's probably isolated, I think, from the environments, from like outside of the browser. Commons rendering engines blink, render directly to a texture. So I try Vulkan texture and then use it into Godot's. Interesting. I think there's a problem in deleting the BM slider. It might be because of the, I'm not checking. I think that's the problem. So BM. Yeah, because this is the source. So there's a problem that I talked about in the previous stream. I have to check instead of here. Let me think about this. Or maybe I should just pass. But I'm already checking there, so. It's weird because I'm actually checking here. It should be on the remove, I think. So it would make more sense that it's here. Oh, I think it has to be here. So yeah, I'm both hacking straight into Godot and also creating modules. But this one, which is basically the same thing, like it's very similar. So this one I'm creating as part of Godot because I don't think it makes a lot of sense to make it as a module, but it's basically a class that is a class that I'm creating to try to serialize the signals. So basically save the signals. But since I'm creating the sync from the code, if I use the connect signal, it doesn't save the state. So when I try to open the sync from the editor, it's not aware of the signals because the signals only work on runtime. So I created this class to make the connection of the signals based on the state of the class. And then because I make based on the way that of the class, on the state of the class, when I save the scene, it's gonna save the properties of the class with the new state, so that the editor is gonna be aware of the signal connections. But it looks like that's like is giving me a dangling pointer, so I think there's something going on here. Obviously there's something going on, I'm not really sure what it is. But it's maybe I should check just see if it's an empty string, but that doesn't make any sense. Actually, I have an idea. I'm going to go over to the debugger. Yeah, that's what I'm gonna do. Then I can see the stack. Also first hack my code in Godot. What is Godot CPP? I'm gonna test first with the editor. Then I'm going to, if it doesn't work, I'm going to go over with this one. Mm. The way to have custom code. There's a library that is linked against the Godot. Some stuff works without recompiling Godot. Oh, you're talking about the GD extensions? I think you're talking about GD extensions. It's basically the same thing. But as far as I understand, GD extensions, you have lower access. You don't have access to everything. And I found, like, I didn't want to spend the time to understand the build process. So since I already know how to do with modules, it's just easier now to do with modules, I think. Yeah, and also, like, because I don't understand very well how it works, I also know that dynamic linker libraries are more of a security risk because you can like hijack or whatever, because it's the operational system that puts the dynamic linker library. So obviously I don't understand how it works. So like I just try to avoid. But I think at some point I might try to understand how it works and then use that as well. So it's fucking up still. The good thing about the extensions is that you can use any language you want, as far as I understand. So that's better. That can be very useful in some situations. The way it's running on the client, so that's nice. Yeah. I'm just gonna remove that one. Yes, it's on the other one anyway. That's interesting. Oh, I think I pressed F5 there by mistake when it opened the thing. And that's the reason why it opened the game, I think. Now I think hmm. So this is the error. Oh, it's got name. So it's because it. Oh, I should check. Huh. Yeah, so it's trying to find the roots. It's trying to find the node that doesn't exist on the roots. I forgot to check for that. I think this is the problem because like it's gonna try to do it twice, I think, because one time it tried to remove after the node removed events. But it's kind of weird. Oh no, it's because like the connection was done based on the two nodes, so the when I deleted the first one, it disconnected the signal, and then when I delete the target, it's gonna fuck up here. So the problem is that each time I'm disconnecting one node, is gonna disconnect for the first one in the first time, and then it's not gonna have here. So the question is whether or not I need here. I think I don't need if I check on the other. Sure. Just return here, return there. Then I delete from here. This should solve there, I think. I'm gonna put on this one as well. I'm not using this one anymore, but has to be after. That should be targets here. So I think I messed it up on the other one. Oh no, it's correct here. Correct. I'm gonna put on the other, connect all nodes as well. Oh, this is the one that I was thinking about that I had to check. That I didn't check. But this one I didn't put a check, I think, because it happens after all the nodes already on the tree, but either way, it does make sense to check because maybe you put the wrong name there. And I can put a message as well and then change the... the problem with putting the error message is that I'm not really sure, because I think when you put the error message with the macro that they use for error messages, and you put the return type as an error, it's just going to return the function. And obviously I don't want that. I just want to log the message and then continue on the iteration there. So I would put pass inside of here, I think, and like put a message and then pass, and I can use print log, I think. No, it's print something, but that wouldn't be the error message. So I think I'm just gonna leave it like this. I can use print line. The problem with printf or print line is that the way that the message is shown is not the same as the error message. And I am using print line for a situation there where I'm expecting like to fail, because it's not really a fail. So I think it gets kind of confusing. And the problem, I don't know if they have a error macro that doesn't return the function. So if they have that, then I probably would use that, but warn print v formats. JavaScript Blender missing. Yeah, I think I'm just gonna leave it like this. And I think about this later. Maybe a print line is fine. I don't know. I think I'm just gonna do a print line and whatever, because it doesn't really matter that much, and it's probably not, if there is an error like this, it's probably not gonna happen that often. But there's, yeah, I don't know. So I leave a print line for now, and then I think about an error message. Well, like the situation where this would happen is if I put the wrong name when I'm subscribing, I think. So it's gonna be annoying either way to figure out. I think this one doesn't matter. Oh, here I should remove this one. I just remember. Because I'm already checking now here or here. So I'm just gonna remove. We are salão, permissão por nós. Bom, just deu, cara. Oh, valeu. Obrigado. É estranho falar em português, porque eu tô acostumado em falar inglês. I think I'm just gonna remove this and try to do it without this. Yeah, now it should be fine. So I have to stop here. I'm gonna have to spend some time thinking about. I think it's very hard to know like what is the best way to go about the headless code because I'm not really sure how it's gonna develop, like what I'm gonna do. The first thing that is very clear on my mind that I'm gonna do is just the editor layouts there in the beginning, but I don't know what it's gonna be. How can I structure things in a way that it allows me to develop from code and from the editor at the same time? It's kind of difficult to think about. I think the hardest, like it all comes down to the tree state. So, because everything is always going to be a tree, obviously. So, the other thing I was thinking about is that it's possible to create like multiple different things, and it should also be easier as well. So, I should probably, but actually, I don't need to change anything if I do that, if I want to do that, because I already have the functions there. So, all that I would have to do is just create another packaging like outside of the other codes, and then I could create like the whole thing from the code. So I think the main thing to think about is the algorithms that's like the structure of the algorithms that are gonna shape the state of the tree. I think this is the fundamental parts. So you have asynchronous development, like the construction and the construction and reconstruction of the sync tree is going to depend on the cache. So it depends on when. So you have like this fluctuation of the tree states based on cache. And the fundamental parts is what is the best way to synchronize the states if you want to develop in a way that you can assume that the code, you can like, in the same way that you develop normally, where you just write the code and then the code runs as if it's running from the beginning, let's say. I think that's probably, like, this is the challenging part, because if you change, if you change from the editor, I think this thing about the name is probably the best, but it's kind of hard to think about as well, because if you do it based on the name, then it does allow you, like if you check the names based on the state, it does allow you to always start as if it's the same state. But I think that it's kind of complicated to think about because of the other nodes. So like, how do you, because you, essentially each time that you're gonna have to reconstruct the tree anyway. So maybe there's two main parts, I think. Like, it's becoming more clear on my mind. So the first part is this thing, because the thing that matters as well is the state of each node, which is the properties, which are going to be reflected on the sync file. So one thing is, like, obviously every time you're coding, you want the newest state to be the one that works. Because let's say you are developing a scene, and then at some point you are going to add, like, you add a bunch of nodes here, but then for whatever reason you decide to change the state of this previous node. You don't want the scene to be reconstructed in the same way always, which is the way that I'm doing here, which is basically checking to see if the name is the same, and then if it is, you don't do anything. Then that's bad, because then the first time you add a node, it would be that node forever, and you wouldn't be able to make the changes. So obviously the conclusion from that is that what you have to do is, if the node already exists on the tree, you have to remove the node and add the new one each time. But then what I just thought about now is that it makes a lot more sense to, like, reconstruct the whole tree from the beginning. So what I could do is just, when I'm extracting the scene state, I can maybe keep a cache of the whole state. I actually, like, this is the problem. So I think I have to traverse the tree, reverse and remove all nodes with the pattern, the name pattern from code. So all the nodes that were created from code, we're gonna have the prefix. So I could traverse the tree and remove all the nodes. But this is like also very difficult to think about, because the difficult part is when you have different levels, and one level, like the editor layouts, the editor nodes that the nodes that were built from the editor can be like dependent on the nodes from the code. So the question is, like, how do you extract them and then, like, you place them on the same spot? This is only one of the problems. The other one is that if I increment based on a global variable each time, then there is a chance that if I reorder the order of the class, the way that I'm adding the classes as children of other classes, that is going to change the number that they are equivalent to. So I think that the name has to be based on the type and the global. Like, it would be better if the global integer that keeps track of the count should generate unique names is based on the class type. So, like, for example, every time you add a mesh instance 3D, it starts from 0 and it counts from that point. In the way that I'm doing now is just a global variable, so, like, there isn't any nuance like that. So just gonna increase for whatever type it is. And that's bad because of the reordering. So just remove unknowns with the name pattern from code. Should make sure if the order is changed. Obviously, the problem, like, I can think about a good way to, because I would have to create a new static variable every time that the new type is added there. I guess I could like get, like one possible solution I think would be to get all the types from class DB, and then generate a unique thing for each one, and then do based on that. But I think that's not very good. I could put them on a hash map, I think, based on the name, and then make the get no name should be dependent on the type, then look for the global cache, get the static. Maybe that's a good solution, actually. I don't need to use class B. I can just use the... So instead of this, I can do a hash map. This might be the solution. So I do a hash map that of string name and integer, a global hash map. Then I check for the type there, and then this might work actually. So I think that to find the name, you use get class name. So on the connect signal function, or the connect function, I'm pretty sure that they have that. Is this get class name? So maybe I can use this one. And this would be the class name here. And maybe this would work. And then here I just put us. I'm gonna test with this. So this way I keep a global cache that maps the type of the thing with the counts. And then increase here. Then I would have to remove here. I'm gonna delete all of them. See if I can delete if it's solved. Yeah. Tempted to disconnect a non-existing connection from. So maybe it's better to. Yeah, I think I have to check to see. So I check to see if the name exists or if it doesn't, instead of the signal. So the problem that is getting there is because I'm disconnecting all the signals. I forgot that. And I'm doing this way because it's a lot easier to do it this way. Like if I had to think about the specific signals that were actually connected, I think it's a lot harder. So basically here I have to check. But the question, I think I left like this because I knew that you would check instead of the disconnect. It wouldn't crash if the signal didn't exist. I think that's the problem. Because here, like this function is going to run every time that the node is removed from the sync tree, but there isn't a way to check which ones. Actually, I can check based on the subscription. But I'm already getting from this. So this is the map that I'm using to keep track of the signals. And this is weird, actually. But you disconnect the non-existent connection. Maybe it doesn't matter that much. Maybe it's because of the index, but I don't think. I'm just gonna leave it like this because I don't think it matters that much. It might be because of the other error. Obviously I can test later. But it's kind of weird to me because I think the error is saying that it's trying to disconnect a signal that doesn't exist. So, because this is gonna, but the problem is that this is supposed to remove all the signals from this dictionary here. And this dictionary is updated based on the subscription. So if you put the signal here, if you didn't put the signal on this, if you didn't subscribe, then you wouldn't have the signal, the name on this connection here. Which means you wouldn't get the value on the disconnect, on the loop, on the info here. I think I'm gonna leave it like this. Oh, and I understand why it's happening. It's because it's adding twice. So it disconnects the signal twice because of the target and the node, and I have to check the target and the node because I don't know which order is gonna happen. If I remove the target from a signal, I have to disconnect because otherwise it's gonna be a dangling pointer if I leave it there, or it's gonna get the error. Like it's memory leak, I think. So the problem is that like because I don't know based on this function which node I'm going to receive, or the target or the source, whenever the target is disconnected first, it's going to disconnect the signal, but I'm not updating the value of this dictionary here. And the reason why is because the dictionary has to have the same state, because the purpose of the class is to cache the signals. So I don't want to, because if I remove the signal from the dictionary every time that the node is removed, then it would defeat the purpose of the class, because the reflection of the state of the state of the class would be a reflection of the whatever happened at runtime on the scene state. So in order to avoid this, obviously I need to keep the same. So maybe I could check here, but the problem is, like, it's kind of difficult to think about a way. So maybe I can ask ChatGPT to see if there is an easy way to check whether or not the class is connected. But I think it's not that big of a deal, because, and this is something that I've looked into when I was setting the connect for the first time, I saw the message there that, like, they designed the connect and emit, I think, or the connect and disconnect, so that it works regardless of whether or not the node exists at the moment of the emit, because there was an issue before there, and now they're copying the memory instead of the connect. So in case the node that is emitting, or in case the node that is either connecting or emitting the signal is removed as the function is being called because of the multi-thread thing, it still works because it copies the memory. So inside of the connect function. So I'm gonna ask ChatGPT to see. Yeah, so. Oh, I think that, yeah, that's the reason why. So maybe I should put the condition there. I think this is the thing, because, like, it is kind of weird, because I remember that now I remember that the reason why I created this other dictionary here is exactly because of that. So this dictionary keeps track of the connection of the signals, but I'm not putting on the subscribe and unsubscribe. So maybe I should put here as well. I don't think it matters for solving the error, but it's probably better. Sure. Oh no, I am erasing from here. It's probably better to leave here as well. But basically the way that is working is that after I connect the signal, I put true here. After I connect the signals for the name, for the source. Oh, I should put the, oh, so, but I'm not using this one. And here I'm always connecting from the source. So it doesn't make sense, true. But maybe I should put for the target equals true as well. Not really sure. I think I'm just gonna put targets equals true here as well. And then equals false on the other one. So if it is connected, then it's gonna disconnect here on the disconnect function, and if it isn't, it's just gonna return. So here on this function, I'm checking to see. So if it is false, it means that it is, or maybe it should be the other way around actually. If it is false, it is not connected. Yeah, so if it is false, it's not connected, then it returns. So it is this way. If it is true, then it is connected. So it doesn't return. Maybe if I put both, you fix. I thought only putting the source would work because that's how I created this. I should map the source with a boolean. It is kind of weird. Yeah, I think putting targets not maybe it was because of the other error that I got there. And then after I fixed. So I'm gonna try to not like just keep the way, because it might be because of the other error that I fixed already. But I'm gonna leave this one here because whatever. So the fundamental thing that I have to think about is this thing, the relationship between the node and the tree state. So I think the fundamental, I'm gonna do some stuff on SkyDraw to think about. But the fundamental thing is like we have two different states. You have two different tree states because two different tree states that are bridged, supposed to be bridged by the cache. I know, so someone's asking if I know DSA using C++. I know like very basic stuff, but I don't know very well. I don't know the low level management, like memory management and stuff like that. And so far, I've only used the abstractions that are already created. It's like from the standard library, vector, stuff like that. Or from other libraries that people create. And Godot already has everything on the fundamental, so they already coded all the algorithms. But I do want to spend some time at some points studying it. I think the first thing to start on your own is to learn the build system. So I think that probably Code Academy is the best way in the beginning because it has exercises, so you don't need to build, and they teach you the basics of building. So I think the first thing to do is to learn the build system. Then after you learn the build system, you study other libraries or code from other people to see how they usually structure things. But I think that before you even do that, then it's probably better to just focus on the basics, very basics first. I'm just drawing stuff on SkyDraw. I'm gonna run from here. Basics RP. So. Yeah, I think that the advice that I always give to people is to break down. So Like it's always gonna be, so like every time that you're trying to learn something new, it's always gonna be overwhelming in the beginning because there's a bunch of things that you don't know. But it's not necessarily that it's hard, it's just that you have to break stuff down to the level that you can understand. And the process of breaking things down is just by like trying to do things, and then naturally questions are gonna come up because you're not gonna be able to do it. So like either you're gonna look for the stack trace, whatever messages show up there, or you're gonna try to do it like, let's say you don't know anything at all. So I just told you to start learning the build system. So if you just sit down and open the IDE and then you try to build like you don't know everything, so naturally these questions are gonna come up. So okay, like how do I do this? What is the first thing that I have to do? Oh, probably I need to know commands. Like, so what command I use? Oh, probably people develop tools for this. So what tools people develop? What are the trade-offs between the tools? Why the tools exist? So like these kinds of questions are gonna be the starting exploration of how to understand things. And there's always going to be trade-offs between everything. There's always going to be two sides, and the complexity is going to be somewhere along the middle of the range. So you're always trying to look for the extremes and then understand the complexity and the trade-offs that exist on the middle. And in C++ is going to be make. Make is the main, is the like beginning, let's say, the fundamental thing. Then on top of make, people used CMake. So make is a language that allows you to put code on a file that creates a command on the command line that allows you to compile C++. So a compiler is another program that is going to have a sequence of rules and tokens, and it's going to transform one string inputs into another string outputs, and that string output is the interface to the hardware. And sometimes it's going to use the operational system to, actually all the time it's going to use the operational system to communicate with the hardware. So the instruction set architecture is the main fundamental entry point. That is the bridge between the hardware and the operational system. And it defines the structure of the compilers, because the compilers are the pathway from the strings that make up the state of the language and the language that is directly connected to the hardware, which is basically an agreement people made to run code on the hardware. So from binary information, you have logic gates. So logic gates are either 0 and 1s, which are made out of transistors, and the structure of the transistors in relationship to a voltage, that is a clock that is going to be running at a certain frequency, is going to set the bits on the hardware. No problem. But from that state that the clock creates, the hardware is going to have a bunch of different components, which are the collection of logic gates that make up the components. And there's going to be certain parts of the computer that the purpose of the bits is going to be to synchronize the different parts. And the main thing that the most important thing is the addresses, which is how the hardware is going to store the data. And the data, which is the fluctuation of the bits on runtime, which is when the program is executing, you're going to change this information of the bits through the calculations of the arithmetic logic unit that the hardware has to determine what's going to be shown on the screen. So an easy way to think about this is that the computer is just a calculator. So based on the voltage of the clock, the frequency of the clock cycle determines the voltage of the computer, which determines the state of the bits that create the logic gates. The collection of logic gates creates the structures that determine the calculations, that determine what bits are going to be turned on or off, and like what's the color between them. And all these processes are being coordinated by different parts on the computer that have logic embedded into them to determine whether or not there is transferring of information from one part to the other. And then it's possible to encode rules to this by creating a convention where you determine that at certain states of the hardware, instead of setting up a bunch of bits to determine that, use something called an EEPROM, which is a tool, like a kind of like a tool that allows you to encode static logic. So like you predefine that these sequences of zeros and ones are going to be the letter A, for example. And this other sequence is going to be the letter B. And this is just a convention. And then from this translation into this state of binaries that represents the concept, you're able to put them together to create commands. And that's basically what a program is a collection of statically programmed abstractions that are just basically rules that people create. And this is called the instruction set architecture. So from that point, you're going to have other languages that are going to be built on top of this baseline, which is the instruction set architecture. And this is going to define the compilation process. And the compiler is just going to be basically a program that takes the language and transforms into the instruction set architecture, which is the lowest level. So the first part is to figure out which compilers are used and why they're used. Then once you understand that, you're going to understand the commands. So the first one is going to be make, because is like the problem with make is that as far as I understand, it's a lot harder to compile code for different operational systems using make, because different operational systems are going to interact with hardware in a different way. And this is the reason why people created CMake, because CMake is a cross-compile make, which means that it's a language that allows you to compile for different platforms in an easier way. Because what the language is doing is building a command on the command line. The command line is another program which receives an instruction, and that instruction, the command line is like the bridge between like the user and the hardware, let's say. So it allows you to, is another language that allows you to communicate with the operational system so that the operational system can do certain things. And one of these things is to execute the compilers. So from CMake, you're gonna code the stuff on CMake. That's gonna, and then you're gonna run the CMake executable, which is the program that is CMake. And this is gonna, CMake is gonna communicate with the operational system, and it's gonna, the operational system is gonna, I'm not 100% sure what's the separation, but basically CMake is gonna create, based on whatever code you put there, is gonna look for the C++ files that you have on the project, and it's gonna create object files, which are the compiled version of the C++ files. And then after that, it's going to link the object files. And then after the linking process, where it connects one C++ file with the other based on the dependencies, it's going to generate the C++ program, which is the executable. So the executable happens after all the files are compiled and connected with each other. I always felt like if I could go back in the beginning, it's probably not going to be better for everyone, but for me, and I think there are a lot of people like me, like instead of learning from the syntax, like most people do, like because I learned on Free Code Camp in the beginning. And the main question I had in the beginning is like why certain keywords make sense, like why certain keywords the program the language can understand, and why other keywords it doesn't, like what decides if something has meaning or not. So I think it would be much better but it's very hard to do. To teach from the standpoint like of trying to the whole process of learning. I think programming is just highlighting this pathway of how the abstraction is created with the binaries, and I think that's much more important than learning any framework or tool, because the frameworks or tools are just abstractions that are built on top of the binaries. So the fundamental parts is it is mathematics basically, because a computer is just encoding mathematics in space-time, I think. Yeah, actually, I think I've heard on a lecture there on C++ that I was listening to that someone said that mathematics is a very small subset of computer science, but I think it's actually the other way around. I think that computer science is just a subset of mathematics. And the reason why it works is because of the connection of the complex plane with space-time, because it is a bridge between the two. So imagination or abstraction is a lower resolution version of space, which is connected through time. So it's a funnel of information. So on one side we have the complex plane, which is imagination, which is basically the internet. It's how the bridge is the internet, I think. Like how imagination becomes space, happens through time. And the connection of them is computation, which is the frequency of awareness over a reference frame that creates the structure of space and time, I think. So this is the reason why I think the mathematics is kind of flawed. It's not perfect because it has embedded assumptions into it, because the concept is already an oversimplification of the boundaries between things. So the notion of identity is embedded into the scalars because the scalars represent a lower resolution level of reality. So the boundaries are simplified in order to, because it is a funnel. So the imagination has like higher volatility as well. So like as imagination becomes reality, the boundaries change, which determines the multifractal nature of the present, which is always relative and a self-fulfilling prophecy in a way. So the main thing that I was going to talk about here is that I think that this is the biggest, like the problem that I have there fundamentally, is that I'm going to have two 3D states, and they're going to be different depending on the stage of development. So like here would be, for example, editor, and then here it would be code. So this tree is the one created through code. This tree would be the one created with the editor. And then what determines the rates of evolution between of the both of them is time, obviously. So like I think in most situations, because of the nature of space and time, like I said, is going to be like this is going to define the relative boundary of the polarity that makes up the complexity of information, which means that for most situations, probably we're going to fluctuate for on both sides, but this boundary is always relative because it depends on the circumstance. So the frequency of fluctuation from both sides is going to depend on the variance of data that defines them, which means that this is going to be a sine function probably. So it determines the fluctuation of the trees of sine function. But obviously, like I don't think that it would be very hard to determine something based on the sine, or like to figure out how to encode this with the sine function, because I think that's more a matter of, because the question, unless I do meta programming to try to create some function that's updates the state, but I think that's way overly complicated. So even though I have somewhat a degree of confidence that it's going to be like this fluctuation of one side to the other, and probably one is going to be more frequent to the other, just based on the way that things usually work. There's also like the amount of output, I think, because the editor is lower, so that's another thing. So even if the frequency in which you develop from code is smaller, there's more potential to create like to add more state on the tree. So I think it's gonna probably and this is the funnel that I'm talking about. So code would be abstraction, which is imagination, and the editor is like space, and they're connected to the time. And the boundary between the two is a multifractal that is relative, that creates the illusion of geometry. Because the boundary doesn't exist, the boundary between things that don't exist is a convergence of time, which is scale. So the question is, they're going to be synchronized through the cache, which is the sync file, and the question is like how to merge the gap between the two, because the tree is going to be a mixed state from the editor and the code, and the distinction that I'm creating between the two is going to be based on the name pattern. So I think the line is going to be multifractal, but I'm not really sure like if there's a way to. I think like it's a lot easier to think about manually, but I'm not really sure how to go about it. Either way. Yeah, but it seems that it's working now. It's keeping track of the integers based on the. So I should put. I'm gonna test if I put another node there. So, but it is what I wanted here. So like all of them are 0 now, because it's gonna increase based on the time. And it doesn't matter if I change the order now, if they're based on the type, because actually it might matter because of the state, but I think it doesn't, because then it's going to recreate the nodes anyway if I do it in the way that I'm thinking, where I'm always going to get the state of the new node, so it doesn't matter the order anymore if I separate by class type. So what I'm going to do is just add another one after connects here. Oh, nah, I'm not gonna test because it didn't change. So I'm just gonna add like this. And I wanna see if it's gonna increase there, but I'm pretty sure that it is. So I think this way, so yeah, now I'm gonna have to spend a bunch of time after I do this. Because obviously the easiest fix there should be able to add one as the child of the other. It should just change whatever I put here after this condition, or the checks. I can replace the node, so remove the node from the tree and then add it again, but it's not the best, I think. It has to be something that is related to the pattern name that allows me to, regardless of the evolution, I have to figure out algorithms that allow me to synchronize the state regardless of the structure. So let's say for example that the nodes in blue are nodes added with the editor. No, nodes in blue are added with the code, and nodes in pink, I'm not really sure, green, nodes in green are added through the editor. This is the case that I'm concerned about, because then it would be very annoying, like because for each node I would have to remove the node and then add the new one. So if I remove this one, I would have to like change the pointers basically, so that this one's points to here, and then replace later. But I think it seems way overly complicated. And this is the problem, because from the code's point of view, it's not gonna have, like, I'm not gonna be able to hard code unless I do meta programming, like I said. But I think that's might be way overly complicated. So maybe. So like, for example, with meta programming, what I could do is just, like, after I retrieve the state, I would compare the state somehow, and then I would like dynamically create the new code that would add the state that was changed. But I think it's just way overly complicated to do this. It is possible, but it's not. It doesn't seem that is the best approach. But I'm not really sure which way to go about it. Yeah, there's something weird because it's taking a long time to load. Yeah, didn't work. Hmm. It's because of the order, probably. Better. It's because I'm increasing, so I have to increase after, but then that's the problem. I think that's the reason why I was increasing outside there. Yeah, so I have to remove this. So maybe I put this here. And then I put increase later. Oh, this is kind of weird as well. It's kind of confusing me, like what is the difference from before? Because here I'm gonna be checking the current ones, which is kind of weird. Like what was making a difference? Oh, it's because I add after, so after it runs, it should have like increased the counter. Yeah, so the problem is that this is not, so, but maybe I can, like, can I do this? I think this is the problem. So maybe if I do it like this. Actually, maybe not. I think it doesn't matter. I think it's because I was adding before. So I probably can do instead of here and just add after I get the name. But it's weird. Actually, it's weird because. It's weird because even if it was adding before, it was like the next time it should be one on the first time, I think. Oh no, because initialize as 0. That makes sense for be 0. But then on the second time it should be 1. Because it should have. It's whatever. I don't have the name here. I'm gonna put there as well, just for now. Then I'll think about it later if I make it work. It might be because of this, like I'm doing this way to add here. I can also try with the static there instead of the hash map. I think it has to be static probably. So here inside, because this might make the hash map static, but it doesn't make the whatever is inside of the hash map static. So I'm gonna try this next. I'll have to run there. It's taking a very long time. And it seems like it ran a bunch of times now, which is kind of weird. So I think there might be a problem that like it's not closing the executable. I'm pretty sure I checked the last time that I did this to see if it was running after I executed there, but maybe for whatever reason it changed. Now it's saying a bunch of stuff here. But it seemed like it closed. It's showing like it ran a bunch of times, and then it's showing that something was leaked here. Well, it might be because of the other one didn't close, and then I ran right away. I think I should probably go back, maybe, like, because it's kind of weird that it doesn't close the program after it executes. I have to press Ctrl C there to stop. It doesn't close the process. So, but I remember like the way that I did this is by putting at the end of the main iteration the check to see if headless is running. Because when I was putting at the beginning of the function, it was giving memory leak or something, another error. So maybe if I try to put before the main rendering cycle runs is better, and then it closes the thing. But I'm not really sure. I think it's because of the way that they designed there. And the problem with this is that I don't want to spend a bunch of time looking to the other builds from other operational systems to see if I change something to see if it still works. And that's the reason why I put instead of the main the iteration. So I put it at the end of this function. And the one that calls this one for the current build that I have, which is Windows, is going to be OS Windows, I think, or something like that, or Godot Windows. It calls this function. But then if I change the function outside, then I have to change on all the operating systems. But if I change here, I think all the OSs use the same functions from the main. And the problem with this one is that I think like it's going to return a boolean. So I'm just returning false here, or true, and then it stops the iteration on the other. And then is the other is like outside of this that is gonna do the cleanup of the scene. So there might be something like with the, but I'm not really sure if it's the like it might be the way that they designed the Windows calls to stop the process. That should be, sure. So if this is true, then it breaks. Then this is the one that is supposed to clean everything up, I think. I do remember it's kind of annoying to find the function as well. So like the last time that I found, when I was having this problem of the error message there, I was finding where the function is being run through the error message. And here, yeah, I think. But I'm not 100% sure if this is the one that it runs. I think it might be on the sync tree or something. I'm pretty sure that if it runs this one, it's gonna run another one as well. Because I do remember looking inside of this function here, and there was like calls to clean up more stuff. I guess I can try to put in the... So it didn't do anything. So I can try to put in the beginning of the iteration to see if it still works. Because that's probably better, and it doesn't have to run one iteration. It's probably something I did then. Maybe because of this. It's probably, but I didn't put static there. I didn't compile after putting static. There has to be something to do this, because it's happening after I change this, so. Oh, also, I'm not supposed to, I shouldn't initialize this as 0. Well, now it didn't leak anything. Oh no, it's because I'm printing here. That's why it's showing there. I think it's... that's weird. Oh no, it's leaking. No. Yeah, it must be because of the pattern here that this is happening now. I think I'm going to stop streaming now, and I will think more about this, because like this is the main problem here that I was talking about. So the thing that I'm not really sure what to do or how to do this, like it's gonna come down to algorithms here. So the main thing is like how do you change. So it's algorithms and cache, because the main thing that connects both of this is going to be the cache, which is the sync file cache. The sync file cache is the bridge that's supposed to synchronize the states. So the delta, which is the difference between the states, is going to be synchronized based on the algorithms here. Yeah, so I think that this delta, it determines the structure of the algorithm. The spreads between states determines the structure of the algorithm. And the way that they are synchronized, there's also different ways to do it, I think, based on the first way that I was thinking about is versioning system. Like we put a version on the code and version on the editor, and then based on the version, you structure the code. So that's, you can synchronize the state. I think that this would involve as well meta programming. So you would like generate the code to update the state from the most recent one using meta programming. So generate files at build time that's based on the state. They add the necessary code, they add the function calls basically that would update the tree, would update the code being used to create the tree, should take into consideration the new nodes added from the editor. But I think that's like, it's sure complicated. And it might not be possible to do this stuff like the way that I'm thinking about. Regardless of what happens in the editor, you can always run from the code as if it's the beginning. Unless like I make a rule to always separate the nodes created from code and the nodes created from editor, so I don't have a situation like this where you have one level created by the editor and another level created by the code, because that's where the problem is. So like if I can always create components based on the code, then it works, but then is a problem because it defeats the point, because then you might as well create a class which would be its own node, which would encapsulate the scope. So it only makes sense to do the composition, which is to use functions to connect different nodes if the boundary doesn't make sense, like to put all the code in the same class. So in those situations, makes more sense to put on the headless code where you build the tree from different nodes. But if that's the case, then it's very likely, I think, that there's going to be a lot of situations where you want to mix nodes from the editor and nodes from the code. That's the problem. So I think there's three options. One is the one that I talked about, where you create a distinction always, which is not very good. The other one is the meta programming, I think. And the third one is to look into cases by cases. So like I would have to think each time that I'm creating a project, what's going to be the order in which I'm going to do things. And also, depending on what I do on the editor, I just manually change the code so that it reflects the editor. Like, or I just like start the project from the code always, then comment the function out, then I do whatever changes I want in the editor if I want to do that. And then I create algorithms for each project that take into consideration the most recent state. I guess another approach like along these lines would be to create but I think it would be the same as changing manually. So create something that always, the function that runs always gets the most recent, and then it just interacts with the most recent state. So I always assume that, so I can have two different types of functions, I think. So one function would be for creating everything, the layout in the beginning, for example, and the other types of functions would be where they always assume a new state, and then they add whatever they want from that state. I think that's probably a lot easier, actually. Because like in this situation, you would... but the problem is like, how do you fix? That's the issue. Because let's say you run the function twice by mistake, you would add the amount of nodes 2 times, and you would only want one time. So like it would be bad because every time you would pass, you would need to, like you would only be able to run one time the code to see what it looks like. So I'm gonna stop streaming because I have to spend time thinking about this, but probably next time that I stream, I'm just gonna continue to just think about this. I think that this is more important to focus before I create the editor layout, because it's the thing that I think is most tricky about this, because there could be like problems where it could fuck up a whole project if I do this in the way that is not the best. So, but if I spend too much time and I can't figure out, then I'm just gonna compromise and do what I said, which is look into a case by case basis. And then I have the baseline, which is the one that I have now, which just never adds new nodes, because it checks to see if the node exists based on the hash set. If it exists, then it doesn't add. And I never change the state after I create from code. That would be one way. And then from the beginning, like from the baseline, I would look into a case-by-case basis where I would just comment out the function, the entry point function for the project. So like after I ran this and I was like happy with the initial state. So for the initial state, it's easy because I can create another function that just eliminates all the nodes from the tree. So I could like test as many times as I want manually. Then after the first initial state, which would be the layout of the project, for example, I could just comment out this function and then just create each function each time, depending on what I want to do there. Assuming that's gonna have the most recent state, and then don't do the pattern checking on the name. Yeah, but I'm gonna stop here. I'm gonna think more about this next time. Probably gonna continue to do this. I'll see you then.